Hello students, welcome back. Let us resume our discussion in section 1, limit and continuity with graphs. Previously we talked about this graph and the key technique is to follow the graph from the left hand side versus the right hand side. For instance, if you're interested in x equals to 2, you can follow the graph from the left hand side like this. And you can follow the graph from the right hand side like this and see where the y-coordinate gets closer and closer and closer to. About 1 2/3. But then again, that's rather trivial, isn't it? And that's because we have continuity here. Nothing fancy is going on, and we can simply read this y-coordinate there. Something interesting happens when we have this potential break here or there, and whether you follow from the left hand side or the right hand side, you may end up with different y-coordinate values. The left hand side limit versus right hand side limit. We can do the same thing here. From the right hand side we get this. From the left hand side we get that, and they're the same, they merge together. But if you go over to the function value, it's in some different place. Again, here we have seen some different place. So those are potential problems, and that's when we have discontinuity, otherwise continuity. We went through that. Now let's consider the other aspect. Things like this. When we have asymptotes, vertical or horizontal, the limit value L can be infinity. You see, the limit here, this expression here, or one-sided limit, this expression here, or there, L1 or L2. Those can be infinity, positive or negative infinity. So as I approach the C from the left-hand side or the right-hand side, function value may go up to positive infinity or negative infinity. I mean the y-coordinate is blowing up to positive infinity up or negative infinity down. That's when we have vertical asymptote. Another situation, C is infinity. So as x approaches to positive infinity, so x is going to positive infinity, so I'm moving to the right. And then what happens to the y-coordinate? Looks like it's coming down to 0. To the left, looks like it's coming down to -1 when we have horizontal asymptote. And that's the kind of thing that we can do. And here are example problems. Let's answer the first problem first. F of -2, when x equals to -2 here, function value, well, there's no dot. So this is undefined. That was easy. If we had dot somewhere, right here, for instance, then we can say function value is, say, 2, and we can move on. If there's a dot right here, we can say the function value is 1, and we can move on. Nothing there, so we have to use undefined. Now, let's go to something interesting. Limit 2 minus, so I have to approach the -2 from minus direction, from the left-hand side. So, right, let's approach from the left-hand side. So, from the left-hand side, O is going to positive infinity. So that's the left-hand side limit. Now, how about the right-hand side limit? Approach the -2 from the right-hand side, so you have to look at the right-hand side of the graph. So this is 2 plus, so that's right-hand side. And to the right, follow the graph, and it is going to negative infinity. See that? And positive infinity, negative infinity, they are different. So this one here is undefined. Make sense? If you have the same infinity, then you can say this is whatever same infinity. But in this case, no. Now, if you go to the next problem, oh, never mind. Let's do next problem next time. It's too messy. I can't do this. So let's erase all these. And erase these two. Instead, I can show you the answer key here. And then let's go to the next problem here. Another point here, x equals to 1. Okay, all right, that's something to think about. In this case, f of 1 is undefined. If we had any dot here, say here, then -1, we can say. If we had a dot here, -1.5, and you can mark there, but nothing there, so we have to say undefined. Now, how about the left-hand side limit? X is going to 1 minus. Right-hand side limits, x is going to 1 plus. Well, this is the left-hand side limit because we have 1 minus. So x equals to 1 is here, and approach from the left. So left-hand side portion of the graph, and then follow, and it is going to positive infinity. Now, what if I approach from the right-hand side? This one, this limit. That's the right-hand side because we have 1 plus. So 1, right-hand side, 1 plus. Plus side is this way. And follow the graph, closer and closer and closer to 1. What do you have? Again, positive infinity. They're the same. So the common value here is positive infinity. So this limit exists. Previously, this limit did not exist because we have plus minus split. But this time, no split. They drag. Same direction. So positive infinity. And there's the answer key. Now, how about those associated to horizontal asymptote? When x is going to negative infinity versus x is going to right-hand side, positive infinity. Left-hand side, right-hand side. So x is going to negative infinity. So I have to go to the left. And this is getting closer and closer and closer to y equals -1, it appears. Now what about the right-hand side? Limit toward positive infinity. I've moved to the right. Go to the right, and this is getting closer and closer and closer to y equal to 0. So that's going to be this limit. And we have finite limit like this. That means we have horizontal asymptote. Now, what if I do not have horizontal asymptote? For instance, if this graph had been not like this, but going up like that, then I have to say this limit is positive infinity because, as you can see, y-coordinate is going up and up and up and forever. You can clearly see the pattern. Of course, that was not the case here. In this particular case, the graph was going down like this and closer and closer and closer to the x-axis. So we do have horizontal asymptote. So that was the alternative case when we do not have horizontal asymptotic behavior. In this case, both to the right and both to the left, we do have horizontal asymptotes, so we do have limits both ways. Indeed, here's the answer key. To the left, going to -1. To the right, going to 0. So, limit an infinity or limit toward infinity. You have to look at the asymptotes. Horizontal asymptote for x is going to positive or negative infinity. Vertical asymptote for limit value is going to either positive or negative infinity. So, we went through both types. Asymptote type versus breaking types. And if you have neither breaking nor asymptote, then that's just continuous graph, so just too trivial. And by the way, here are some commonly encountered infinities. Limit 1 over x is going down to negative infinity when x is from the left-hand side, and x is to the right-hand side, positive infinity. Here's the graph. So I'm going from, let's see, let me color code this. Okay, how about this? Approaching 0 from the minus side, 0 minus left hand side. So this is left hand side. So approaching to 0 from the left hand side is this one. No wonder that's going to negative infinity. Now how about the right hand side? This one here, 0 plus 1 over x, and you follow this graph from the right hand side. No wonder it is going to positive infinity. Now how about infinity in denominator? Look at these graphs here. Either way, both this one here and that one there, either way, they are going down to y equal to 0. So 1 over infinity is 0. 1 over plus infinity versus 1 over minus infinity, no difference there, because plus 0 minus 0, there's no difference there. But 1 over 0, that's a little bit different. 1 over 0 plus versus 1 over 0 minus, we get different infinities. Oh, by the way, plus 0 versus 0 plus, they're different. Plus 0 or minus 0, that's just 0, because this is just plus 1 times 0, positive 1 times 0. 0 times something is 0. So plus 1 times 0 or minus 1 times 0, they're all the same. But 0 plus versus 0 minus, there's a world of difference there. We encountered those. 0 plus is this behavior here. 0 minus is that behavior down there. They're different. Okay, that was 1 over x type. And here's an exponential function, e to the negative infinity 0, e to the positive infinity 0, and similar behavior about logarithmic functions. And you can see those from the graphs. To the plus infinity going up to positive infinity, easy. Negative infinity going down to 0. See that? Easy to see. Look at the blue graph. And how about logarithmic? Plus infinity this way, very slowly, but it goes to positive infinity. To 0, it goes to negative infinity very quickly. And logarithmic functions must have positive number inside, so we can never have 0 minus there or equal to 0. It has to be 0 plus. And you have to look at the red graph for logarithms. There are others, but these are the most common encounter. Okay, that concludes section 1, and we'll discuss limit rules and limit computations when we do not have graphs in sections 2, 3, and 4.